Happy morning, my dear children. Today our learning objective to learn about the extraction of aluminium by Hall Herald process. Here we are extracting the aluminium and about next learning objectives to learn about what are the refining process of metal. That is the first one is about that distillation. Second one, liquidation. Third one is the electrolytic refining. Let us see, can we discuss one by one. Please all of you take the note.
Dear children, today our learning objectives to learn about electrochemical extraction of aluminium. Electrochemical extraction of aluminium. That means by Hall Herald process, how the aluminum is extracted by Hall Herald process. Dear children, in this method, electrolysis is carried out in an iron tank. Electrolysis. What is the meaning of electrolysis? Electrolysis means electro means electric current. Lysis means splitting. So simply we can be say the splitting of ions by means of electric current. One of the substance, from that substance ions are splitting by means of electric current. Okay, electrolysis is carried out in an iron tank. First, we have to take one iron tank, one of an iron tank. This is one of an iron tank. This iron tank is lined with the carbon. That is the inner part. Inner part of the ion is lined with carbon. Okay, carbon. Here this carbon acts as cathode. Okay, this carbon acts as the cathode. Here we are taking a block of carbon. We are taking a block of carbon. This we can be take as anode. My dear children, can you say what is the charge of cathode and what is the charge of anode? The charge, this is a positively charged anode. Okay, positive charge. Cathode, it is one of the negative charge. Okay, don't forget that the charge. Okay, then here we are taking one of an electrolyte. Which electrolyte means 20% solution of alumina. This alumina is obtained from bauxite ore. Bauxite, can you say what is the composition of bauxite ore? Can you say which one is present there? What is the formula? Al2O3 NH2O. Am I right? This is the one of the ore of aluminium. And also this bauxite ore is mixed with molten cryolite. This cryolite is also one of the chief ore of aluminium. Okay, cryolite. Don't forget that. Cryolite is also one of the chief ore of aluminium. What is the cryolite formula? Na3Al F6. These are some one word, my dear children. Try to take this one word, okay? Cryolite. Here we are taking electrolyte. Which are the electrolyte we are taking? 20% of alumina that is obtained from bauxite ore. This bauxite ore is mixed with molten cryolite and also 10% of calcium chloride. 10% of calcium chloride is also added to the solution. What is the purpose here we are adding calcium chloride means? It helps to lower the melting point of the mixture. Okay, that is lower the melting point of the mixture. In the lower section, we maybe learn about that, about the electrolysis. Am I right? That is about that we are simply taking one of a tank, maybe an iron vessel or any one vessel we are taking. We are taking that is a two electrode. One is an anode. Anode means the charge is about the positive, and another one is the cathode. Am I right? Is the charge is about the negative. Here we are having one of an electrolyte. What is an electrolyte means? Suppose we want to purify copper. Copper metal means in the anode we are taking impure copper. Cathode we are taking thin sheet of pure copper. The electrolyte means here we are taking the electrolyte means copper sulfate with acidified dilute sulfuric acid. This is the electrolyte. Okay, but this electrolyte is entirely different from the electrochemical extraction of aluminium. That is not like that. Here, this iron tank is lined with carbon that we can be act as a cathode. What is the charge of cathode? Negative charge, am I right? Here we have a number of blocks, carbon blocks immersed in the electrolyte. Here having some electrolyte. That carbon blocks are immersed into the electrolyte and is act as the anode. That means a positive charge. Am I right? Here, what are the electrolyte here we are using? A 20% solution of alumina, that is aluminum trioxide, that is obtained from bauxite ore. And this ore is mixed with a molten cryolite, that is a G4 of aluminium. I told you about the formula. What is the formula? Na3Al(F6). And again we are adding 10% of calcium chloride is added to the solution. Am I right? Anyway, what is the purpose here we are adding calcium chloride? To lower the melting point of the mixture. Then the fused mixture is maintained the temperature. We are maintaining the temperature of above 1270 Kelvin. Don't forget that this is also one of the one-word question. The fused mixture is maintained at the temperature of about 1270 Kelvin. Okay, my dear children, now we can write the equation how the chemical reactions are involved in this process. How the chemical reactions are going. Okay, first one. The electrolysis means we can be say it is one of an ionization. Am I right? Ionization, because there's a charge or produced. One is about the cation and another one is anion. So first we have to write ionization of alumina. Ionization of alumina. That is Al2O3. Alumina means Al2O3. this undergoes ionization. That means we are saying splitting. Electrolysis is one of the process. Splitting of ions by means of an electric current. Am I right? Splitting this aluminium oxide undergoes splitting into ions. Which are the ions? Al 3 plus oxygen is 2 minus. There's not a few. Here having 2 aluminum, so make it 2 aluminum there. And oxygen having 3, so make it 3 there. Here we get one of the charge. How we get this charge? Aluminium. What is the atomic number of aluminium? It's 13. Atomic number of aluminium is how much? 13. Am I right? That is the first shell we can be accommodate 2 electrons, second shell 8 electrons, that is the remaining 3 electrons, am I right? Here 3 electrons are lost during the electrolysis. Before that we can be learn about what is about the electrolysis. Is the one of the process by which the electric current is passed through the substance. It's split into ions, am I right? Now, another one more point about the electrolysis. It is one of the chemical change in one of the substance loses or gain an electrons. That we are saying oxidation or reduction. Loses means we are saying oxidation and gain means we are saying reduction. Am I right? The aluminium having 3 electrons in the outermost shell, it loses its electrons, am I right? So, how much electrons are lost means, they are here having 2 aluminum. Okay, here having how much aluminum is there? 2 aluminum. 1 aluminum lose 3 electrons. Another one aluminum also lose 3 electrons. Total how much electron is lost? 6 electrons are lost. Am I right? 6 electrons. Don't forget that. How much electrons are lost? 6 electrons. So we have to write once again. What is the reaction at cathode? Reaction at cathode. So again you have to write there 2 aluminum. How much electron is lost there? 3 electron. 3 plus is for 1 aluminum. 2 aluminum means we can be write about that 6 electron. Am I right? So this is a fused state. We can be write melting. Am I right? Melt. Fused state. Am I right? So I told that 1 aluminum is 3 electrons. 2 aluminum is how much electron? 6 electrons. So 6 electron, the charge of electron minus, all of you know that one. We get aluminium metal, Al. Aluminium metal, that's in liquid state. Am I right? How much aluminum is there? 2. Listen all of you. What's the meaning? What is the meaning here means? Here 2 aluminum loss 6 electron, am I right? So we have to add 6 electrons. We have to add 6 electrons to aluminum ions. So we get aluminum metal. Can you understand me, dear children? It's a loss of electron. Aluminum loss its electron. So, how much electron loss? 6 electron loss. So, we are adding 6 electrons. So, we get aluminum metal. Reaction at anode. Reaction at anode. What happens? Reaction at anode. The reactions, we wrote that the reaction, right? Anode. Here, anode having oxygen, am I right? Oxygen. That is about oxygen, one of an oxygen. The charge of oxygen is All of you know that one. 2 minus, am I right? 2 minus. This is also fused state, melting, melt. We get oxygen molecule here, O2. Okay. So, plus electrons, electron. In the ionization of aluminum, first equation we wrote that on aluminum also we get oxygen. I mean, how much oxygen is there? 3 oxygen. Am I right? So make it 3 oxygen. 3 oxygen in the product side, 3 oxygen. So we get the 3 molecules. 1 oxygen, 2 electron loss. Am I right? 1 oxygen means minus 2 minus. Am I right? So 3 into 2. 3 into 2 means 6 oxygen. Am I right? 6 oxygen. That is how much electron? 6 into 2 is equal to 12 electrons. Am I right? So 12 electrons. So what is about the product side? Here having 3 molecules means you have to write 6 atoms of oxygen. So now the equation is balanced. Yes or no? Can you understand, my dear children? Next, we wrote the reactions at cathode and reaction at anode. The carbon acts as anode. So how the reaction taking place? Can you understand? Carbon acts as the anode. Then how the reaction can taking place can be written as carbon is a solid state, combines with oxygen. What is the charge about oxygen? That's 2 minus. This is also fused state. We can written as melt. What is the answer here? What is the product here? Carbon combines with 1 oxygen. We get carbon monoxide, and also here having one charge. So 2 electron minus. Clear? Second one, carbon solid state. This one combines with 2 oxygen. That is 2 minus. There is also fused state, melt. Carbon combines with 2 oxygen. We get CO2. That is 2 oxygen means carbon dioxide. Am I right? So 1 oxygen, 2 electron means 2 oxygen, how much electron? 2 into 2, 4 electrons. 4 electrons. Okay. Next. Here having 2 reaction. In these reactions, anodes are slowly consumed during the electrolysis. Anodes are slowly consumed during the electrolysis. Here pure aluminum is formed at the cathode. Where the pure aluminum is formed? At the cathode. And settled at the bottom. Settled where? At the bottom. So now we have to write the net electrolysis reaction. Net electrolytic reaction. Listen, all of you. In the ionization of alumina, there we write on equation. After that, we wrote on equation that is a reaction at cathode. Am I right? Here, 2 aluminum is there. Am I right? 2 aluminum, 3 plus 6 electron, we get aluminum metal. Am I right? Yes or no? So now we are writing on an equation, net electrolytic reaction. Aluminium 3 plus on reacts with oxygen O2, 2 minus oxygen, oxygen, only oxygen 2 minus, say fused state, we can write melt. In the presence of carbon also they are having, because before that we write the equation about the carbon. So what is the reason we are adding carbon means carbon reduced into carbon dioxide. I mean, carbon combines the oxygen, we get carbon dioxide. One is of reducing property. Am I right? Next we get aluminium metal. There is a pure form of aluminium metal, Al, aluminium metal. This is a liquid state. Carbon combines with oxygen, we get carbon dioxide. So how can you solve this equation? How can you balance the equation? Here we can be written as 3. We are multiplying by 3. So here carbon also we get 3. Oxygen, 3 2s are 6. Am I right? 6 oxygen. So make 6 here. Okay, 6 here. And in the reduction at cathode, here also having 6 electrons. Am I right? 6 electrons. In the below reaction, they are having 12 electrons. So for cancelling 12 electrons, here you have to multiply it by 2. This equation we have to multiply it by 2. So 2 aluminium, we are multiplied by 2 means we get 4 aluminium. Am I right? 4 aluminium. And 6 electron, we are multiplied by 2 means we get 12 electrons. So this 12 electron can be cancelled. Here also we are multiplied by 2 means we get how much? 4 aluminium liquid metal. So first we have to 4 aluminium ions we get. So make it here 4 aluminium ions. So here we get what? 4 aluminium metal. Okay. Now the equation is balanced. Okay. Okay. Can you understand, my dear children? Okay. And if you have any doubt means please ask me. Okay. Next about we can be learn about refining process. Refining process. What is about the refining process? In the metal extracted from its ore containing some impurities. Some of the impurities may be oxide ore impurities, other metallic impurities, sometimes maybe non-metallic impurities, etc. are having in our metal. Am I right? So refining process means first we have to remove the impurities. How can you remove the impurities? The removal of impurities associated with the isolated crude metal is called refining process. In the crude metal, they are having some unwanted impurities. These unwanted impurities we have to remove first. That process is called refining process. Here having a number of process there. Number of process. One is about that. Distillation. What is about the distillation? Here, the impure metal is heated. We are heating the impure metal. So, during the heating, the impure metals are evaporates. Okay, some of the impurities or some metals have impurities due to the heat. It may be evaporates. And the vapors are condensed to get pure metal. Okay. This vapor are condensed to get pure metal. That means, listen all of you, how means condense. What is the meaning of condense? Can you say what is the meaning of condense? To change. Otherwise, we can be say, make some there change from vapor to liquid. Something change. Okay, one small change from vapor to liquid. we can be say vapor to converted into liquid, that process. Here, which metals are applicable for distillation means low boiling volatile metals. Low boiling volatile metals. What is about the low boiling volatile metals? That means easily evaporating metals. Easily evaporating. For example, zinc. Zinc, and we can take mercury. The boiling point of the zinc is about 1180 Kelvin. About the mercury is 630 Kelvin. Am I right? When we are heating, the mercury metal is easily melt. Am I right? Easily melt. And anyhow, when the impure metal is heated, it evaporates and then vapor are condensed to get a pure metal. That is about the distillation. Next is about the liquidation. Here also we have to remove the impurities. How we are removing the impurities means the impurity having a high melting point from metals, having some metals having relatively some low melting points. For example, some of the tin metals such as tin, about the melting point is 904 Kelvin. Don't forget the temperature. Try to learn, okay, about the one-word question. And about the lead, what is the boiling point of lead? 600 Kelvin. And about the mercury, about the melting point, 234 Kelvin. And about the bismuth, melting point is about the 545 Kelvin. These are some one-word questions. Try to underline this area. Here, the crude metal is heated to form a fusible liquid. This is one of the solid crude metal. This undergoes heating. Due to the heating, it forms a fusible liquid and allowed to flow on the sloping furnace. One of the sloping furnace. Something sloped like that. Okay, some area should be sloped like that. Sloping furnace. That is a sloping surface. You can be say like that. One of the surface area with slope. The impure metal is placed on the sloping surface of a reverberatory furnace. Is one of the furnace for heating. Okay, one of the small type of furnace for heating purpose. A sloping furnace. And it is heated just above the melting point of the metal in the absence of air. Okay, don't forget that. The melting point of the metal in the absence of air. Here, the molten pure metals flow down and the impurities are left behind. The molten metal is collected and solidified. Can you understand here, my dear children? When we are heating, what happens? The metal is melted. Am I right? Or fused. Am I right? So, heating and the melting point of the metal in the absence of air, the molten pure metals are flow down in the sloping surface, and the impurities means it cannot be melt. There is a mostly in solid form. If it is converted into liquid form, then only it can be flow down. Am I right? If it is not melt, means it cannot be flow down. Okay, so the impurities are left behind there, and the pure metals are flowed down, and the molten metals are collected and solidified. This is about the liquidation. Next about that, electrolytic refining. Electrolytic refining. What is about the electrolytic refining? The previous I told that one of the electrolytic refining example I gave that copper. In the beginning also I told about the copper. For example, I am giving the copper. Here we are taking one vessel or maybe one tank. Here we are taking two rods. One is about the anode having the positive charge and another one is about the cathode having negative charge. Okay. Here we are taking one of an electrolyte. For this example, copper means we are taking copper sulfate plus dilute sulfuric acid. Am I right? We are taking. Here the anode. What we are taking in the anode means impure metal. Anode we are taking what? An impure metal is taken in the anode. And about the cathode, we are taking thin strip. That's a thin sheet. We can use like that. Thin sheet of pure metal. Pure metal is taken in a cathode. Am I right? Here we are take some electrolyte. Am I right? Some of the electrolyte. Electrolyte I take that here copper sulfate with dilute sulfuric acid. When we passing an electric current, what happened here? Passing an electric current. In the impure metal is present in the anode. Here the metal dissolve from the anode and pass into the electrolytic solution. And the same amount of metal ions from the solution will be deposited at cathode. Can you understand the concept? From the impure metal, some of the metal dissolves from the anode and pass into the solution. Here the electrolytic solution, here passing. Am I right? Here passing. And a small amount of the metal ions from the solution, here having some metal ion solution, this metal ion solution will be deposited at the cathode. What happened the impurities? That is a question. That is our question. What happened the impurities? During the electrolysis, the impurities in the anode settle down at the bottom and are removed as anode mud. And are removed as what? Anode mud. Anode mud means we are saying waste. Am I right? Waste. Impurity. Then we can be one of the example. I am giving another one more example. Example is about the silver. What is the symbol of silver? Ag. Here also I am taking one of an vessel, taking two rod. One is about that anode, and another one is about the cathode. Am I right? Cathode. The anode is a positive charge and the cathode is the negative charge. Don't forget that. In the anode we have to take impure silver rod, and the cathode we are taking pure silver. Here we need one electrolytic solution. Am I right? Electrolytic solution that we are taking aqueous acidified solution of silver nitrate. Acidified aqueous solution. What is that meaning of acidified aqueous solution? That means that solution containing acid. For example, silver nitrate we are taking means dilute nitric acid. What is the formula for nitric acid? HNO3. Dilute nitric acid plus silver nitrate, AgNO3. Silver nitrate. Here dilute nitric acid that we are written like that, acidified aqueous solution of silver nitrate. What happens when current is passed? When current is passed to the electrode, the following reaction takes place. What is the first about the following reaction? Reaction, first you have to write reaction at anode, that is Ag, yes, that is solid state. This Ag is converted into Ag ions, Ag plus, Ag ions, aqueous. Plus means loss of one electron, am I right? Ag plus means loss of one electron. So one electron minus. Reaction at cathode. Ag plus, that is about the Ag plus means Ag plus ions, aqueous. It lost one electron, so we have to write one electron. That is adding. We are adding one electron. We get Ag, that is silver metal. Here, during the electrolysis, at the anode, the silver atom lose one electron and enter the electrolytic solution. The positively charged silver cation migrate towards the cathode. The positively charged silver cation migrate towards the cathode. It move on the cathode and get discharged by gaining electrons and deposited at cathode. So anyhow, from the anode, silver atom lose one electron. Can you understand? And it enter into the solution. Now the charge of the silver is positive because it is a cation. This cation migrates towards the cathode and get discharged by gaining electrons and deposited at the cathode. Okay. This is about the electrolytic refining, and about that other metals such as copper, zinc also can be refined by this same process. Okay, here one more important point I am giving. Cathode and anode. Here cathode means negative charge. Anode means positive charge. Don't forget that. Okay. Cation. Cation means positive charge. Don't forget positive charge. Anion means negative charge. So don't confuse that one. Cathode, anode, cathode. Anode means positive charge. Anion means negative charge. Cathode means negative charge. Cation means positive charge. Okay, so try to remember that one. So anyhow, today our assignment, write the electrolytic refining of silver. Write the electrolytic refining of silver. Okay, thank you all of you. Thank you. Have a nice day.